Part 2. How to learn a programming language. All right, how to learn a programming language. There are some steps. These things basically apply to programming languages that are not functional programming languages. You have a different approach if you're going to learn a functional language. So for Haskell or F#, that's not how you would go about doing it. This is not how you'd go about doing it. But for things that are, what do I want to say? Programming languages that stem from C. And a lot of them do. Java certainly does. Go is a descendant of it. So is Python to a certain extent, although it does have some different constructs. How to learn it. The first thing is you're going to have to install it. Okay, this can be a hard problem. Getting to the first thing that you run in a language sometimes can take days. And you're banging your head against, system administration and configuration and how do I edit on this system? And, this is not necessarily a trivial thing. Some years ago, I did a bunch of work porting Java code to different platforms and actually rewriting it for some of the platforms to build a quantum cryptography proof encryption scheme called NTRU. And it had been a couple decades since I'd worked on IBM mainframes. And let me tell you, when I had to go back and learn how to use Xedit on an IBM mainframe to edit code, man, did I bang my head against that. And yes, I did get it. But it took solidly a week to get to the point where I could edit a file. And I was working on it every day, like 16 hours a day. I wasn't messing around, man. I was with the program. So install, edit, run, which in this case is compile. And then you want to execute it. Okay. Go has a shortcut for that. You can actually go and you could just say, at your prompt, you can say go, run, and some program. And if you do go, run in a program, it compiles it, stashes the executable off for you someplace, runs it, and every time you do it, it just recompiles it for you. And it is fast. In fact, one of the important things that we're going to talk about Go is not only do we have this capability, but there's actually a tutorial for Go. And that is in the information that I'll email out to you and this set of lecture notes. There's a tutorial for Go. And you can go to the Go tutorial and you can actually go in there and you can compile stuff, you can edit stuff, you can try stuff out. It's 9 pieces in the tutorial. It'll take you maybe an hour. And it will save you hours and hours of time in this class. So go to the tutorial, go run through it. I'm one of the people that helped build it years ago. You can actually get the source code for the entire tutorial if you want to build something similar to it. But along with this capability to, on a website, compile and run code, they also have in their documentation, every time you see a piece of the documentation, there's an example. And there's some piece of code in here. Down at the bottom, there are 2 buttons. Okay, and one of them is run. And if there's an example piece of code in the Go documentation, you can edit it. You want to change the example for how regular expressions work? You can go in, change it, tweak it, and run it. Just like it were a program that you had access to. And manipulate it and cut and paste it after you've run it a couple times and go, oh, okay, now I get how this works. So the documentation is interactive. That is huge right there. So install it. Download Go. Figure out what you're going to use for an editor. I track what I do quite often. I use Vim on the command line a bunch, and I use VS Code. VS Code has the best debugger for Go in existence. So those are the 2 things that I use. Am I reasonably fluent in other things like IntelliJ Yes, I use IntelliJ when I develop applications for mobile. Okay? But I still use Vim about 90% of the time for editing. So, yes, I do use graphical tools. I do know how they work. And I still use Vim because it's still faster for editing. Actually, there have been surveys, and if you want to boost your career, learn how to use VI and learn it well. The last survey I saw from Stack Overflow, they figured that people that used VI earned $14,000 a year more than people that don't. And there is a reason for that. It's a nuisance to learn, but boy, you can do a lot of things with it. Now, the second question, after you've installed it, this is basically install and get to the point where you can run Hello World. Hello World is the first piece of our 9-part assignment on learning the language. And it's maybe 10 lines. It's way shorter than it is in Java, but in any case, cut and paste it, get that to compile. Tweak the print statement to say, hello, your name, okay, so you can see that it actually works, that you're not running somebody else's code. Put it back, try some things, make certain you can edit. Okay, and this is probably a really obvious thing to say to people in senior computer science, but I still see people stumble on this because they haven't gotten to the point where they can build a directory where things are going to work, and they can compile it, and they can run stuff. So get this piece working. Now the next one is how you test code. And Go has a nice testing capability built into the language, so that you can do unit tests, and it's not super fancy. I do use other testing packages with Go, depending on what I'm working with, that are fancier and nicer and have more capabilities, but in this class, we are just going to use the testing capability built into the language. It is reasonably robust, and it's built into the language, and you don't have to mess with learning a new thing. You learn one system. When I go out to GitHub and I survey all the Go code on GitHub, over 1 billion lines of Go code, something like 96% of it, 96.34%, is using the built-in testing package. So this is the common one, and sometimes you need something more, and there are specialized testing packages. If you want to do testing with fuzzing, there's a fuzzing package. If you want to have a more clear test case for some reason, there are ways of doing other testing. You can build your own testing package, but the built-in one is pretty good. Third thing is, how are files organized? Okay, and in the files organized in Go category, you create a directory. The directory is going to be the name of your program. If you just do Go build in that directory, it will compile the code in that directory and stick it into an executable based on the directory name. So each directory basically gets its own code. Can you have more than one main program in a directory? Yeah, there's a way to do it. But the default is one directory, one program, and a whole bunch of things that you pull into that program that are modules. And it has a package manager and modules that you import from. The modules are interface-based, not objects, and there is a huge, I'm talking hundreds of thousands of lines of code, sets of libraries that come with Go that are really useful. There are other outside libraries, and it's easy to pull them in and use them. In your directory, when you talk about files, there should be a go.mod that defines the version of the compiler and the set of modules that it uses and what it pulls in. And Go is very tied to an internet world. So if you just look at Go mod and you say, oh, it needs this package out here, and you go to compile it, it will download that package from places like GitHub or other Git repositories or BitLocker or a number of other things. It will download those and compile them and put the correct version on your program, on your system, so that you have access to it and compile it. And it just does it for you. So are there sometimes problems with the it just does it for you? Yeah, but not much. It's been pretty darn reliable. Now, I started out with Go 1.2, and every 6 months they have a release. We're at 1.15. So you can figure out how many years I've been programming in Go now. And one of the things that you notice, this is still a 1, although they're now talking about Go version 2. It's not here yet. There's at least going to be a 1.16 before Go version 2. Go version 2 is going to address the biggest complaints people have about the Go programming language, which is that there's no generics. And it turns out that's not as big a deal as you might think. Yeah, it's a little bit annoying. But the other things in Go more than make up for the lack of generics. So they're going to have them in a year. They've got a test compiler out there you can try. But they were serious about this being version 1, and code that you wrote in version 1 will compile in any version going forward, without change. That's not been universally true, but inside the set of Go libraries, inside all of Go, with everything that they've changed and added to the language in that time period, I have seen one case where one thing changed. And that was an additional field in a single structure that you had to go add to a test case in somebody's code. And if they'd done it the recommended way, this wouldn't have happened. They did it the non-recommended way, and you had to add an extra field. And I am talking about in millions and millions of lines of code. Go is forward compatible. So, every year they have a Go conference, and at the beginning of the Go conference they put up a slide that says, what are the changes in the Go language this year that you will have to deal with? And every single year they've used the same slide, and it's empty. So what are the different versions between Go 1.0 and 15? They've made the compiler faster. They've made it do a better job of compiling. They've made the linking process faster. They have added some features, but they are additions, not things that they modified that cause you to rewrite code in the past. So stability is one of the big features. One of the things that they have added in Go 1.11 is this modules. And it is possible you will want to compile things that does not use the Go modules stuff. If you go into a Go program and you don't see the file go.mod, then it's not set up for modules. There is an environment variable that you can turn off modules if using modules is causing you problems. It probably isn't, but it's possible. That environment variable is Go 111 modules. And you set that equal to off. And that turns off the module stuff, and you can compile stuff without the module interface. But yes, most of the time, I just use Go modules all the time. And there are some weird edge cases where you may need to turn it off. If you have two different packages that you've built and they're codependent on each other, we'd ask the question, why are they codependent instead of one dependent on the other? But it does happen eventually. If they're codependent and you're modifying both of them at the same time, then you're probably going to want to turn off modules, and that will save you some headaches. Otherwise, you will have to be checking stuff in and tagging it and stuff like that to get it to work with the modules. Other than that, I haven't found any problems with the modules. And this was added after almost a dozen versions of the language. So, Go modules. Now, modules are directories with a path. So when we do something like we do import, and usually you'll see a paren, you'll see github.com, and usually some sort of person. And then this is the same line, I just don't have space here. Pschlump and some module like mislib. If you go out to GitHub, https://github pschlump mislib, you get to the directory in which that is, or the package in which that is, where it is going to download stuff from. And this creates something in your code called mislib. Now, you can have multiple things in a directory and paths to it. This path doesn't have to be just too deep. You can use your own server and set up Git on your own server. Say, you run a server easy to see why, and you want to have Git on it. You can use your own server in Git. It works just fine with that. You can set up stuff locally. If you're inside a business and you want to have a GitHub repository that you're developing inside the business, you can set up a local repository with a domain name. Git is perfectly happy to work with that just as well. It's relatively straightforward to install Git and make it work with this. So this is a fairly flexible and comprehensive way of working with code. But when you have a Go modules, it creates another file called go_sum. And go_sum has the exact versions and hashes that you compiled with when you did this. When you did set up your thing and you did go mod init, okay, it fixed at that point in time the modules that you are using. And if you add a new module, it will add that to go_sum. Now this means that you're compiling against a consistent environment, but this also means that if somebody updates something, you're going to have to go out to go mod and you're going to have to look at it. It's a text file, it's got an obvious format, and you may want to tweak the versions of stuff, recompile things, and it will update go_sum as to the exact modules you're using. This means when you build stuff, you can use different versions in different directories. It's perfectly happy with that. And that's kind of the files. They're text files ending in .go. And the nice thing about Go's system is it is post Unicode, so that in terms of files, as far as I know, you can have Unicode file names as long as they end in .go. And you can build things with Unicode in your code, and it all works very happily together.